So today I am going to discuss about the glucose biosensor. As I had already discussed about the biosensor, how they work, or how many types of biosensors are available. So this is the most popular or most commercially successful biosensor, which is known as the glucose biosensor, and it is actually an amperometric biosensor. Amperometric, that means these are the devices which are based on the measurement of the current resulting from the redox reactions. So this glucose biosensor is actually an amperometric biosensor. This was first used by the Leland C. Clark. Leland C. Clark, he used this biosensor for the first time to detect the glucose in the sample. The enzyme, actually, you already know that in any biosensor, there are two components. First one is the bioelement, and second one is the sensor element. So for bioelement, here this enzyme was being used, or this enzyme is already used. This is glucose oxidase enzyme. So you already know that for bioelement we can use enzyme, we can use antibody, we can use nucleic acid, anything which is the biological material that can be used as the bioelement. So any change in the bioelement is detected by the transducer or the sensor element. So in this glucose biosensor, they have used glucose oxidase, which is an enzyme. And as you already know, that enzymes are highly specific. Enzymes are highly specific and they react only to their specific substrate. Suppose here they used glucose oxidase enzyme. So here it only reacts with the glucose substrate. So this is highly specific. So when any bioelement or any biomaterial is used, that material is highly specific. So now we come to the glucose biosensor. In that experiment, which was carried by the Leland C. Clark, he used electrode which was made up of platinum, right? And this enzyme was very closely placed to this electrode. So he used the enzyme which was very close to the platinum surface. This the activity of this enzyme, it changes depending on the surrounding oxygen concentration. Now, when glucose comes in the contact with the glucose oxidase, it forms gluconic acid. When it forms gluconic acid, it also produces protons and electrons. So, glucose, when it comes in the contact with the glucose oxidase enzyme, it is converted into the gluconic acid and it also produces protons and electrons. So, now it becomes reduced glucose oxidase. Now, what happens? It actually uses the surrounding oxygen. The oxygen which is available there, this glucose oxidase reacts with the surrounding oxygen as well as with the protons and electrons and restores its original form. Like it becomes oxidized again and now it is ready for the next reaction for the next glucose molecule. And in this process, it also produces hydrogen peroxide. So, what happens? These changes are detected by the electrode. So, electrode can either detect the consumption of oxygen or it can detect the production of H2O2. So, either it can detect this or that. So, it can give the output. So by using glucose biosensor, one can easily detect the glucose concentration level in the blood. As I already told you, Leland C. Clark, he used platinum electrode. But as you all know, that platinum is a very costly metal. So it made it restricted to the labs only. So now the biosensors are basically made up of graphite electrodes. The electrode which is being used these days, that is made up of graphite, and this graphite electrode is separated from the glucose oxidase by the isolating layer, one layer which is in between the glucose oxidase enzyme and electrode. So this layer actually it actually filters out the interfering substances. It actually keeps them away, and it allows the passes of hydrogen peroxide and oxygen. So by using glucose biosensor, we can easily detect the glucose concentration of any sample. Thank you.